Good morning, children. Myself Gopi ma'am. Children, in the last two slides or last two PPTs, we already discussed about three states of matter, basic properties of matter, and the comparison between solid, liquid, and gas. Children, yesterday I sent you some question answers also, which you have to write down in your notebook. I want this homework and whatever the topics we discuss in your chemistry notebook. Now children, today we will continue with our chapter number 1, matter in our surrounding. Today we will discuss about interconversion of states of matter. What it means that the three states of matters are converted into each other by action of heat, the action of temperature and pressure. Okay, so children, first we will understand what do you mean by interconversion of states of matter. Change of state. When a solid is heated, it changes into liquid. When liquid is heated, it changes into gas. Children, here the temperature comes in a play, or temperature play a role to convert solid into liquid and liquid into gas. When gas is cooled, it changes into liquid. When a liquid is cooled, it changes into solid. The reverse process is there. In a first case, the temperature is increased. In second case, the temperature is decreased. I am giving you one example. Children, ice is heated, it changes into water. Water is heated, it changes into steam. If steam is cooled, it changes into water. If the water is cooled, it changes into ice. Here, the conversion of states of matter, solid into liquid into gas. Inverse, gas into liquid into solid is shows in the figure. Solid state, heated, liquid state. The reverse process, when liquid is cooled, it converted into solid. Liquid is heated, it converted into gas. When the gaseous state is cooled, it's converted into liquid. Now what is the basic concept behind this conversion of states of matter by action of temperature? So then here you are having a one figure. You just see the first one, we are having ice crystals, the molecule arrangement of ice. Tightly packed. Now children, what happened? By increasing the temperature, the particles are close together and cannot move when they are in a solid state. When we apply the temperature, you can see in the second figure, they start vibrating at your place. Hai na? What they are doing? They just start vibrating. They are moving away from each other. Children, if you remember, in a 7th standard, you are having one chapter, heat. Solid expand on heating, liquid expand on heating. Why? Because when we apply the temperature, the kinetic energy of molecules are increased. They start vibrating, they are just move away from each other. Simple example I am giving you, children, you can understand it very nicely. अगर घर पे आग लगी है तो आप क्या करोगे? भागना दौड़ना स्टार्ट कर लोगे, है ना? सेम यहाँ पे यही है. Temperature बढ़ रहा है. Particles are start vibrating at their place and they are just start moving away from each other. Now what happened then? When ice crystals are start moving away from each other, they are creating a space between them. Their intermolecular space is increased. Now they reach at a one level when they are converted into liquid. Same phenomena is applied when we apply temperature or when we apply heat to the liquid. Now what happens in the liquid state? More intermolecular space is created. They go away more from each other. So slowly it converted into steam. The particles move faster and further apart. The particles are far apart and move very quickly and randomly. The two things are there. When the temperature is increased, particles are start vibrating. Second thing, as they start vibrating, their kinetic energy is increased. So this is a basic phenomena behind conversion of state of matter when we apply heat or when we increase the temperature. I am repeating one sentence which you have to listen it very properly. Children, when temperature is increased, molecules start vibrating at their place. As they start vibrating, their kinetic energy is increased, which leads to allow them to move away from each other. as they start to move away from each other, the space between the molecules, the space between the particles are increased, which leads to increase intermolecular space, decrease intermolecular force of attraction, and slowly they convert it into next state, solid into liquid, liquid into gas. Children, in a last lecture we already discussed that gaseous state is having highest kinetic energy and solid is having a minimum or negligible kinetic energy. Because this is tightly packed, this is having a more intermolecular space. Now children, here a diagram is repeated in this slide which exactly shows the effect of temperature. So our main topic is today, what is the effect of temperature on different states of matter. The particles are close together and cannot move because it's a solid state, tightly packed. When you apply heat, which is called a melting process, solid converted into liquid. Now what happened in liquid state, the particles move faster and further apart, which converted into steam. The particles are far apart and move very quickly and randomly. So children, here we are having a one process which is called melting. The another name is fusion. When a solid is heated, the particles begin to vibrate with greater speed and begin to move more freely. Then at a particular temperature, the solid melts, change into liquid. Now children, in this statement, the most important thing is particular temperature. Children, melting point is a fixed temperature at which a solid converted into liquid. Now each and every material is having a fixed melting point and boiling point. Why? Because it depends on its molecular arrangement. Now children, what happened at a particular temperature, the particles are start vibrating. Each and every material is having a different type of molecular arrangement. Now why we require this temperature? This temperature is required to break down the intermolecular force between that molecules. Now if different particles are there, different molecules are there, different substances are there, so obviously we require a different temperature to convert or to negligible the force of attraction and convert it into next state. So what is the important thing is here, then at a particular temperature the solid melts and change into liquid. The process of melting is also known as fusion. The temperature at which a solid melts is called its melting point. The melting point of ice is 0 degree Celsius or 273 Kelvin. So children, here we discuss about a melting process. Now the next topic is latent heat of fusion. Children, what do you mean by this word latent heat? The word latent means hidden. वो कहीं छुप गया है, हमें दिखाई नहीं दे रहा है. Why? Children, at a 0 degree Celsius we are having two states of water, ice and water. Two states are there, solid and liquid. बेटा हमारे पास 0 degree Celsius ice is also having, we are having 0 degree Celsius water is also having. Why? The amount of heat energy required to change 1 kg of a solid into liquid at atmospheric pressure at its melting point is called latent heat of fusion. Now what is the meaning of this statement is that I am applying heat. The temperature is increased. Slowly solid particles and break down the force of attraction. Solid particles are converted into liquid. Now children, what happened at a one stage, I am applying the heat but the temperature is not increased. As I told you, whatever the heat I am applying, it is used to convert it into liquid state. तो हम जितनी भी extra heat दे रहे हैं, it used to break down intermolecular force. It is not used to increase the temperature. This particular heat is called latent heat of fusion. Children, you can see here we are having a beaker which is having both the state, ice and water, and the temperature is 0 degree Celsius. What it means that the temperature is 0 degree Celsius but both the states we are having, solid and liquid. Now if we continue with this, applying the heat, At a 0 degree Celsius, the temperature is not increased. Still, whatever the ice crystals are there, not converted into water or liquid state. This heat is called latent heat of fusion. So children, today whatever the topics we are discussing, you have to note down in your notebook and you have to send me the clicks of the homework whatever I am giving to you. Children, I will track a record of the notebook, record of the homework whichever I am giving to you. Have a nice day.